We are proud to present you with the world first from the research department of Rampf Formen GmbH. In the following film, you will see by means of detailed animations a whole new technique made by Rampf. Flexway is the name of the mold sliding system which increases the lifespan of concrete molds many times over. See for yourself. Here you can see a simplified view of a standard production sequence in a block production line. Only the most important components are shown. In accordance with the machine manufacturer's installation instructions, the lower part of the mold has at least 1 mm freedom of movement on all sides. This means that this part can move 1 mm to the right, the left, backwards and forwards in relation to the center. In comparison, and depending on the type of blocks produced, the tamper shoes have an all-round play of only 0.3 to 0.4 mm within the mold cavities. This means that in the case of a horizontal movement of the mold bottom, the tamper head must move to precisely the same extent to ensure that the tamper shoes fit correctly into the mold cavities. The movement of the tamper head is indicated by the flashing red arrows. The required displacement of the tamper head results from horizontal shifting by extreme direct force exerted on the tamper shoes via the mold frame. This shift can occur in every cycle and requires the application of extreme force. After demolding, the tamper head returns to its original position. Therefore, the tamper shoes must be recentered in relation to the lead-in chamfers of the mold cavity before the next cycle, as shown here. This also involves extreme direct forces, and both the tamper shoes and the mold cavity are subjected to extreme mechanical loading. This can lead to increased wear in the centering and final compaction components, as well as the mold cavities and the tamper shoes. Because two resistances have to be overcome, the direct forces from contact between the mold cavities and the tamper shoes are very high. On the one hand, the inert mass of the tamper head and the quick change have to be moved horizontally, while, on the other hand, the rubber buffers between the compactor plate and the quick change device have to be tensioned in the horizontal plane. These rubber buffers create an extremely powerful reaction force that constantly presses the tamper shoes against the mold cavities. This extreme reaction force is present during the centering process and throughout the entire duration of the main compaction phase. For instance, in the case of a compaction time of 3 seconds and an exciter frequency of 50 Hz, this generates 150 relative movements between the mold cavities and the tamper shoes. It is obvious that the effects of such powerful forces and vibration frequencies between the mold wall and the tamper shoe lead to extreme wear on both components. If we now make a comparison between an aligned and centered tamper shoe and a poorly centered shoe, it can be seen that the chamfer is clean and constant on all sides in the case of uniform tamper shoe play. However, in the case of off-center tamper shoe play, it can be seen that the play is doubled and that this can lead to burrs, even when using relatively new molding assemblies. This burring usually continues around the corners of the blocks produced. Now we come to the technical solution that can significantly reduce this problem. For this purpose, we have constructed the conventional tamper head in 2 parts. The upper part is now replaced by the Flexway unit. The Flexway unit can be easily mounted on existing tamper heads. For this purpose, the tamper heads are equipped with 2 centering bolts that automatically center the components. The Flexway is simply bolted to the upper part of the mold by means of 6 attaching bolts and is already ready for use. The animated instructions show how the Flexway is bolted to various tamper heads or various mold assemblies. This also clearly shows the particular multi-use flexibility of the Flexway unit. This replacement is carried out away from the running block production line. This means there is absolutely no need to interrupt the production process. The installation of the mold assembly, now equipped with the Flexway unit, is quite conventional and follows the usual preparations and instructions that apply for standard mold assemblies. The only difference is that the Flexway unit has to be connected to pneumatic feed lines after installation of the molding assembly in the block production line. It is no longer necessary to shake in the tamper head. This of course also means that the sensitive components of the mold assembly are treated much more gently. Because the pneumatic brake is released as soon as the tamper shoes are lowered into the mold cavity, the tamper head moves in accordance with the movements of the mold bottom during production. For instance, if the mold bottom moves to the right, the tamper head also slides simultaneously to the right. This is shown here by the flashing arrows. The pneumatic brake is applied again before the tamper shoes are removed from the mold cavities, and this new position is stored for use as the aligned position for the next cycle. For example, if the lower mold bottom moves to the left in the next cycle, the tamper head also moves to the left immediately after the pneumatic brake is released. At this point, the pneumatic brake is activated before the tamper shoes are removed from the mold cavity and sets this current position as the aligned position for use in the next cycle. Of course, both the mold bottom and tamper head may shift backwards or forwards too. The important factor is that the shifts of the two components are always synchronized. The pneumatic brake also ensures that the tamper head is not shifted horizontally when cleaning the tamper shoes with the cleaning brushes installed on the feeding wagon or a lateral cleaner. If we take a closer look at the centering procedure, it can be seen that there is no contact between the tamper shoes and the lead-in chamfers when the tamper shoes are lowered into the mold cavities. The reason for this is the position stored in the previous cycle. However, if the positions of the tamper shoes in the mold cavities should be slightly off-center, the tamper shoes can be shifted very slightly in the horizontal plane until centered. This correction is possible because the pneumatic brake is already released shortly before the tamper shoes are lowered into the mold cavity. This allows anodyne horizontal motion of the mold bottom and tamper head during vibration. The easy movement of the tamper head against the Flexway is achieved by specially designed sliding brushes. These special sliding elements ensure that there is no direct contact between steel parts. The sliding elements are also extremely resistant to wear and soiling, which means that no disruptions of the process are caused by the buildup of dust or other concrete particles. This animated sequence shows the horizontal movement of the tamper head with the yellow base plate of the Flexway unit when the pneumatic brake is released and the upper rubber buffers of the quick change system are not in action. This means that these are not shifted in the horizontal plane and apply no reaction force to the upper part of the mold. As no reaction forces are applied to the tamper head, it is more or less free to move horizontally on the block surface, which in turn leads to a smoothing of the block face and a better surface finish. Simultaneously, this sliding motion is effective in preventing burring for longer periods of time. Flexway, for more quality in your block production process. Flexway, reduced wear ensures improved cycle times and efficiency. Flexway, fewer rejects ensure improved productivity.